Hey guys, my name is Walker Campbell, and I will be talking about the effects that aspirin has on glucose phosphorylase B. I would first like to apologize if I sound a bit off or if I end up coughing. I recently actually got diagnosed with strep throat, so trying to record this while dealing with strep is not so great. Um, but first, I wanted to particularly highlight the reason why I chose aspirin for this experiment when it impacting whether or not it does affect glycogen phosphorylase. So in research, I found that a potential side effect of aspirin is that it can lead to tiredness as well as fatigue. But in addition to it, I wanted to see whether or not a blood thinner would affect this process by interfering with the structures of these enzymes, since blood is the normal way in which glucose travels through the bloodstream, and that's how our cells get it. I wanted to see if a blood thinner, in particular, had any effect on whether or not it made the process slower, faster, or like that. What I did to do this is I had a series of assays in which I ran using an aspirin solution. Luckily, if you look at the inactive as well as active ingredients in bare aspirin, which is the one I tested today, only aspirin, the active ingredient, is water soluble. So all of the inactive ingredients were not present in the solution, meaning that aspirin in particular was the only thing affecting this reaction from occurring. I also provided the structure of what aspirin looks like, as well as the structure of the enzyme of interest, and then just a slight what is it? Slight overview of how glucose is reduced into glucose 1 phosphate by glycogen phosphorylase, and this is the overall reaction that's there. And then, like I said, I wanted to highlight how potentially a blood thinner would impact this process and whether or not it will change it, make it worse, or allow the process to provide more glucose to the cells at any given point in time. So aim of the study, obviously, whether or not aspirin affects this reaction. So how we did this is we first took a standard curve, which is roughly right here with our equation. We will use this later on in order to calculate the concentration of PI of the reaction, which is inorganic phosphate, which is the byproduct of this reaction. So first, I wanted to look at the AMP because AMP is a known activator of this reaction. And so I wanted to first see how does it impact the reaction, what does it do? And as you can see, it has a relatively high velocity with a Vmax of approximately around 2, maybe 1.9, 1.8. And then to compare it to the aspirin, if you look here, when we do aspirin concentrations, you can see that much lower V naught, significantly lower when compared to AMP. And then its V naught is relatively right above 1, probably around 1.1. And so what I made the conclusion was that it appears that due to the Km values, half of the Michaelis-Menten plot of the aspirin being lower than the AMP when comparing the enzyme-free line as well as to the AMP line, that it looks like aspirin does act as an inhibitor and makes it to where this process undergoes slower than it would normally, which perfectly explains why then the potential side effect of taking aspirin is that you feel fatigued or slightly tired due to the fact that your body can be able or is able to less do this process, like the reaction doesn't run as efficient. And so a major future direction I wanted to take was I wanted to see if there was other potential blood thinners out there that I could test that would potentially also act as an inhibitor, or whether or not. So right here, I highlighted one of the major ones that is used. That's typically warfarin. super commonly prescribed over the counter or behind the counter blood thinner, and I provided the structure. Now, the reason why I wanted to focus on this is just because blood, like the overall action, whether or not aspirin's fact that it is a pain reliever is the part that is acting as the inhibitor, or whether the aspect of it being a blood thinner is what's acting as an inhibitor for the reaction. And so that's the major reason why I would want to further look at warfarin's ability and whether or not it acts as an activator or inhibitor. But that's going to be everything for you. Thanks for coming to my presentation. I really appreciate it. And I'm once again sorry about the cough and my voice. Strep is not a very fun thing, and I was hoping it would be mostly cleared up by the time I had to record this, but I was afraid that that was not going to happen. Thank you.